Let's try solving a quadratic trigonometric equation. It says 12 sine squared theta plus sine theta minus 6 equals 0. The first thing to do is let a equal sine theta. It makes your life so much easier, because now you get 12a squared plus a minus 6 equals 0. And this is now just factoring a quadratic, when that's the whole point. This is solving quadratic trig equations. How do we factor this quadratic? Well, we're looking what multiplies to negative 72 and adds to 1. The answer for that is positive 9 and negative 8. So this will factor, but I'm going to need chart method. 12a squared goes here, negative 6 goes here, and my 9a, say, goes there. My negative 8a will go here then. And let's factor this column. What goes into 12 that goes into negative 8? 4 and an a. That leaves 3a over here. If 3a goes into 9a, divide 9a by 3a, you're left with 3. If 4a goes into negative 8a, divide, you get negative 2, no a's. And check, negative 2 times 3, negative 6. I've done it right. So I get 4a plus 3 times 3a minus 2, just looking at my answer in chart, equals 0. And now I solve my zeros. 4a plus 3 equals 0, and 3a minus 2 equals 0. So this side, take away 3 both sides. 4a equals negative 3, and so a equals negative 3/4. On this side, 3a, 2 both sides equals 2, and divide both sides by 3, and you get a equals 2/3. But remember, these are two possibilities for not a, but for sine. Let's substitute back in. Either sine theta equals negative 3 over 4, or on this side, sine theta equals 2/3. So now I've got to solve both those independently. I'll call this 1, call this 2. Over here, I'll solve 1 first. Set up my sketch. This is x, this is y. Where is sine negative? Sine's negative in quadrant 3, and in quadrant 4. Here's my initial arm. So here's my theta 1, and here's my theta 2. Let's solve for that related acute angle x. Using the positive version, we're trying to solve for these x's, so sine x equals the positive version of 3/4. And so, better make sure my calculator's in radians. And it looks like it's in degrees. So I'm going to set my calculator into radians. Going to need a moment to remember how to do that on this calculator. Mode, there it is. Let's go to radians. Okay. So, I want to solve for that. X is inverse sine of 3/4. So, inverse sine of 3, I'll probably need brackets there, of 3 divided by 4. And so we get x is approximately 0.848 radians. So when we solve this one, that means we're in quadrant 3, so theta 1 equals pi plus 0.848. And so on our calculator we can take pi, which on mine is shift down here, there's my pi button, plus 0.848. So one of the solutions, theta 1, is 3.990 approximately. I rounded pi. I rounded this big long decimal that came from pi. Theta 2 is in quadrant 4, so that's 2 pi take away 0.848. I can do that all at once in my calculator. I'm going to have to round again. So pi times 2 take away 0.848 gives me approximately 5.435. But I'm not done. That's only case 1. Those are 2 possible answers. Let's box them. I'm going to cut off that 0. Let's box this one. I have 2 more possibilities here in quadrant. Maybe move over a bit so you can see. Here for possibility 2. What was possibility 2? Sine theta could be positive 2/3. Let's draw a sketch of that. Well, where is sine positive? Sine's positive either in quadrant 1 or in quadrant 2. Here's my initial arm. So let's call this, say, theta 3, and this here theta 4. And we'll solve for the related acute angle. use the positive version. Sine of x, I like to call my related acute angles x, is 2/3, so x is the inverse sine of 2/3. So x is approximately, calculator still in radians. I like to check every time because you never know, if you accidentally turn it back, it ruins your day. Inverse sine of 2 divided by 3, you get approximately 0.730. So, theta 3, we're in quadrant 1, is exactly whatever the related acute angle x is here. I forgot to label those. So we get exactly 0.730. I like to put 3 decimals just to show that I've rounded to 3 decimals. And theta 4 is in quadrant 2. Quadrant 2 is just use 180 degrees and subtract your related acute angle. Except we don't talk in degrees anymore, we talk radians. So let's do pi radians minus 0.730, and we get approximately 2.412. And there are 4 possibilities. These numbers, if you sub them back in, will all solve this original equation.